Hi students and friends, welcome to the channel Learn and Teach by Ayaz. In this video lesson, I'm going to talk about CAI 5070 past paper, and I have selected this time October-November 2022, and the paper is 21. The paper is about theory. It is paper 2. Let's continue the paper. Section A, answer all the questions in this section in the spaces provided. The total mark for this section is 45. Question number 1. The diagram shows part of the periodic table. The part of the periodic table is shown here. Answer the following questions using only the symbols of the elements in the diagram. Each symbol may be used once, more than once, or not at all. Give the symbol of the element that is a catalyst in the hydrogenation of alkenes. You have only one element which is used as catalyst in the hydrogenation of alkenes, and that is nickel. So I will write Ni here. B is extracted by electrolysis of its oxide dissolved in cryolite. Cryolite is added to oxide to get aluminum from its oxide. So oxide should be of aluminium. So I will write Al here. C is a metal below copper in the reactivity series. The only metal we can see here which is below in the reactivity series of copper is Ag. Ag is silver. D is a gas used in welding. Oxygen is used in welding, so you write the symbol O here. E forms an ion with a charge of -1. We have only one element which is forming -1 ion after gaining one electron, so we write the symbol Cl. Question number 2, carbon dioxide is a gas at room temperature. A1, draw a dot and cross diagram to show the arrangement of electrons in a carbon dioxide molecule. Show only the outer shell electrons. First of all, you should know the formula of carbon dioxide. Carbon belongs to group 4. So the valency of carbon will be ±4. And oxygen belongs to group 6. The valency of oxygen will be -2. So ignore their charges. You will get 4 and 2. Now these numbers will be simplified. Both will be divided by 2. And you will get 2 here, 1 here. These subscripts will be exchanged. And in the end, you will get the formula CO2. Now I'm showing the key on the right hand side. For carbon, I'm using dot. For oxygen, I'm using cross. There'll be one carbon atom and 2 oxygen atom. So that carbon atom must be in the middle. This is carbon and 2 oxygen atom will be attached and on right hand side and left hand side. Now I'm showing the valence electrons for carbon. There are 4 valence electrons for carbon. So it will be 1, 2, 3, 4. Oxygen belongs to group 6. So it must have 6 valence electrons. In order to complete its valence shell, they will share 2 of their valence electrons with 2 electrons of carbon atom. So you will get this 1, 2, 3, 4, 5, 6. On right hand side, 1, 2, 3, 4, 5, 6. Question number 2. Describe the motion and separation of the particles in a gas. You have to write the motion and separation of particles in a gas state. Remember, in gas state, the particles are far away and they are moving randomly in all directions. So you have fast or random movement. Fast or random. Now, if we'll talk about the separation, they are far apart. Part B. The main processes in the carbon cycle are combustion, respiration, and photosynthesis. Number one, name the products of photosynthesis. We know that during photosynthesis, plant takes up carbon dioxide and water from the air, and in the presence of sunlight, it produces two products. One is oxygen gas, and other is its food, which is glucose. Number two, some of the reactions in photosynthesis involve enzymes. State the meaning of the term enzyme. Enzymes are biological catalysts, or you can even write catalysts in organisms. Number C, carbon dioxide is formed when hydrocarbons are completely combusted. Number one, name the other product of the complete combustion of hydrocarbons. During combustion, we will always get water as one of the common product. So you'll write water here. Number two, the paraffin kerosene fraction from the fraction distillation of petroleum, crude oil contains hydrocarbons. State one use of the paraffin kerosene fraction. We know that kerosene is used in jets as jet fuel. So you'll write jet fuel or aircraft engines. Kerosene can also be used for heating and cooking purpose. So you can write heating, cooking. It's also used in lamps or in lighting purpose. Question number 3. The alkenes are a homologous series of hydrocarbons. A. Give the general formula for the alkenes. CnH2n will be the general formula for alkenes. B. The structure of an alkene is shown. This is the structure of an alkene. Part 1. Name this alkene. Now, alkene contains carbon-carbon double bond. If you look at the position of carbon-carbon double bond, it's the position number 1. Start counting the carbon atoms, and you will start counting from the carbon which contains carbon-carbon double bond. 1, 2, 3, 4. So you can write But1e or butene. Number 2, explain how this structure shows that alkenes are unsaturated. Unsaturation means it has carbon-carbon double bond. So has carbon-carbon double bond. Hydrocarbons. Hydrocarbons are compounds which contain hydrogen and carbon only. Contains hydrogen and carbon only. C. Alkenes are produced by cracking some fractions obtained from the fractional distillation of petroleum, crude oil. State the meaning of the term cracking. Cracking means breakdown or decomposition. During cracking, we crack long chain alkanes to get smaller hydrocarbons. So you can even give the idea of breaking long chain hydrocarbons to get short chain alkanes. Idea of breaking long chain hydrocarbons. D. Carbon monoxide is formed when alkenes undergo incomplete combustion. State 1 effect of carbon monoxide on health. It's a poisonous or toxic gas. E. Alkenes react with bromine to form compounds containing carbon, hydrogen, and bromine. Number 1, a compound contains 22.2% carbon, 3.7% hydrogen, and 74.1% bromine by mass. Calculate the empirical formula of this compound. We need the AR or nucleon number of carbon, hydrogen, and bromine to carry out this calculation. So you'll write carbon, hydrogen, and bromine. For carbon, you have 22.2 divided by 12. For hydrogen, you have 3.7 divided by 1. Bromine should be 74.1 divided by 80. So for carbon, we will get 1.85. Hydrogen we will get 3.7. For bromine, we will get 74.1 divided by 80, 0.926. So which number is the least here, or which number of moles are the least here? It's 0.926. So we will divide all the values by 0.926. In case of carbon, we will get 1.85 divided by 0.926, 1.997, which will be equal to 2. So you write 2 here. For hydrogen, 3.7 divided by 0.926, 3.995, which means we can write 4. It will be round off to 4. For bromine, you will get 1. So the final empirical formula will be C2H4Br. Number 2, a different compound of carbon, hydrogen, and bromine has the empirical formula C3H2Br. The relative molecular mass of this compound is 236. Deduce the molecular formula of this compound. In order to calculate the molecular formula, we need to divide the molecular mass by the empirical formula mass. So empirical formula is given here. So first of all, I will calculate the empirical formula mass for C3H2Br. There are 3 atoms of carbon. So you will multiply 3 by 12, we get 36. There are 2 atoms of hydrogen. So we will multiply 2 by 1, we will get 2. 1 atom of bromine. So we will multiply 80 by 1, which will be 80. Now I will add up all these values. 36 plus 2 plus 80 will get 118. 118 is the empirical formula mass. Now we will divide the 236 by 118 to get the value of N. N is equal to 236 divided by 118. 236 divided by 118, you will get 2. So we'll multiply 2 by each number of atoms in this formula. 2 multiplied by C3H2Br. So final molecular formula would be C6H4Br2. Question number 4. This question is about ammonia and ammonium salts. A. Ammonia is manufactured by the Haber process. Number 1, name the catalyst used in the Haber process. This is very easy. You know the catalyst. This is iron. Number 2, explain how a catalyst increases the rate of reaction. It simply lowers the activation energy of the reaction. Lowers the activation energy of the reaction. B. Ammonium phosphate NH4 whole thrice PO4 is a fertilizer. Calculate the percentage by mass of nitrogen in ammonium phosphate. Give your answer to 3 significant figures. First of all, we need the MR of ammonium phosphate. So we have 3 atoms of nitrogen. So we'll multiply 3 by AR of nitrogen, which is 14. 3 multiplied by 14, 42. We have 12 atoms of hydrogen, because 4 multiplied by 3, we will get 12. So for hydrogen, 12 multiplied by 1 is equal to 12. Phosphorus, the nucleon number or AR of phosphorus is 31. 31 multiplied by 1, we will get 31. Oxygen, there are 4 atoms of oxygen. So we will multiply nucleon number of oxygen by 4. 16 multiplied by 4, we will get 64. So adding up these together, 42, 12, 31, and 64. 9, 4 plus 1, 5, 5 plus 3, 8, 8 plus 6, 14. So 149 will be the MR of this compound. Now I want to calculate the percentage by mass of nitrogen here. So we have 42 as the mass of nitrogen in this. So we will multiply 42 by 100 and divide the answer obtained by 149. 42 multiplied by 100 divided by 149. 28.187. 28.187. Or you can even write 28.2. Fertilizers can make soil more acidic. Number 1, state the name of a compound used to decrease the acidity of a soil. You can use alkali or basic oxide for this purpose. So you can write calcium hydroxide, or calcium oxide. To explain how this compound decreases the acidity of the soil. It's very easy, simply neutralizes the acid. (4D). Ammonia is formed by the reduction of nitrogen monoxide N2O with hydrogen. The reaction is exothermic. This is the reaction. N2O plus 4H2 gives 2NH3 plus H2O. Complete and label the energy profile diagram for this reaction to include the reactants and products, the enthalpy change of the reaction. The reaction is exothermic, so the product will be on the lower energy state. So if this is the reactant, so we'll have energy hump, and this will be for the product. Now I'm writing the symbols for reactants and products. Reactant is N2O plus 4H2. The product side, you have 2NH3 plus H2O. Now in the question, they have asked to show the enthalpy change of this reaction. Enthalpy change is between reactants and products. We have reactants and products here. This will be the enthalpy change. Part E, copper 2 oxide CuO reacts with ammonia. The products are copper, nitrogen, and a liquid which turns blue cobalt 2 chloride paper pink. Construct the equation for this reaction. Formula of copper 2 oxide is CuO. So I will write CuO. For ammonia, it's NH3. Now the formula of the products obtained for copper, CuO, nitrogen is N2. And they are saying a liquid which turns blue cobalt 2 chloride paper pink. It's water. This is a test for anhydrous cobalt 2 chloride, H2O. Now let's balance the equation. You see on the left hand side, you have 1 mole of copper 2 oxide. There are 1 atom of copper. Copper is balanced. What about oxygen? Oxygen is also balanced. Nitrogen is not balanced. It's N2 on the product side. So I will write 2 before ammonia. This will make 6 moles of hydrogen. 2 multiplied by 3 is 6. So I have to write 3 here before H2O. Now the number of moles of oxygen becomes 3. So I can write 3 before CO to balance oxygen. This makes 3 moles of copper. So I will write 3 on the product side. Now this equation is balanced. Thanks for watching. Press like, share my videos, give comments. For more videos, subscribe to my channel and press the bell icon.